Hi everyone. Welcome to video 33 Encapsulation and Abstraction from H&M Technologies online training. So far in our object-oriented programming journey, we have learned how to build classes, create objects, and share behaviors using inheritance. But as your program grows, especially when you start building real applications that handle sensitive user data, you run into a new problem. That is a trust. When you're running sensitive data like user data, user information, that's where trust issues came. Right now, anyone using our classes can reach in and change your objects data whenever they want. If you have a bank account object, another programmer could just write a my account balance 10 lakhs and suddenly they are a billionaire. That is incredibly dangerous, right? Today we are going to learn how to protect our code using two massive concepts. One is encapsulation and abstraction. Let's start with the encapsulation. Think of a capsule like a vitamin pill. The medicine is safely protected inside the shell, right? In Python encapsulation, building our data, that means our attributes and the methods and operator on the data into a single unit. That single unit is a class and restricting your direct access to some of the objects components. Let's see how this works. Open your VS Code and create a new file called encapsulation or a data protection.py like that. We are going to build a bank account today. By default, all attributes in a Python are public. Anyone can access and modify them. We can change this by using a underscore to make it protected or a double underscore to make it private. Let's write a complete block of code to see in action. Firstly, defining our class with private attributes. Now class is a bank account. Now let's say I'm defining under init. Then here as usual self and parameters owner and balance. Then now I need to define them. Self dot owner and self dot balance. Here we do one change. So owner is a public attribute. Let's make this public attribute. Now the balance is not a public. Owner can see. So that's why we're making this private attribute. To make this as a private attribute, we need to give double underscore before this. Now second, let's create our object. My account, the bank account. Here the owner urgent balance is a 5,000. Okay. Now let's test our code. First test our access. So this I am trying to print formatted output which is like a first type account owner. My account dot owner. See, we'll get output here. Account owner is urgent, is right. It's worked perfectly. Now try to access the private attributes directly. Pen my account dot balance. See, we get a massive attribute error. Attribute error bank account object has no attribute balance. Why did that happens? Because when you put a double underscore in a front of attribute name, Python performs something called name mangling. Name mangling. It intentionally hides the attributes from the outside world. It tells other programs, hey, this data is sensitive. You are not allowed to touch this directly from outside the class. This is an encapsulation. I have successfully locked the vault. Okay, fine. We hide the balance to anyone. But if the vault is locked, okay, how does the account owner check their balance or a deposit money? Think about a real bank. You don't just walk into the vault and grab cash. You go to the bank teller and the teller verifies your request, and they go to the vault for you. In Python, we create a special methods called getters and setters to act or bank managers or a cashiers. They allow control safe access to our private data. Let's write a fresh self-contained script. Again, I'll see that. Now see our class with getters and setters, a class bank account as a previously self owner and balance self dot balance. I'm starting balance. Okay, I'm assigned a new parameter starting balance here. It is a private. Now getter, a safe way to read a private data, get balance self and return self dot balance. Okay, now see this is a getter and setter. Deposit self to amount, and if amount is greater than 0, then self balance amount, and deposit amount new balance. Now let's see test our code. This is a bank account, and here I'm giving the names Ravi, and his balance is 8,000. Now we use a getter method instead of directly access the attributes. Now print format or output. Current balance is my account dot get balance. So we get balance because we created get balance here. This is a getter. It returns the self dot balance. Okay. Now see the output terminal here. The current balance 8,000. This is what we have. We gave amount here. Now we also use the setter to safely change the data, and my account dot deposit 5,000 again. Okay. Now see my account deposit. I deposited 5,000. Deposited 5,000. New balance is 13,000. See output terminal. Because I'm just calling the setter. This is our function I created here. Define deposit if amount is greater than 0 plus amount, and else print a deposit amount must be a positive. I'll try to for this my account dot deposit minus 200. Now see error came. Deposit amount must be a positive. It doesn't be a negative. This is our getters. It simply reaches inside the class and hands us a copy of private balance. Just inside the class, getter is on function and setter is on function. Then we call our functions with data. That's what the work is done. So encapsulation is nothing but hiding our data from public. Now, using a get balance and set balance is very common in languages like Java, C++, or C++. But Python developers love clean, readable code. Writing in my account dot get balance feels a bit tricky. Python gives us a beautiful tool called property decorator. It allows us to access methods as if they were simple attributes. It gives us the safety of getters and setters, but the clean syntax of normal variable. Let's look at a complete example of this decorator. Before that, we want deposit. We use the same my account dot deposit, my account dot deposit, and get balance, my account dot get balance. With the help of decorators, we'll decorate this. See here, I have a class product and define it the name and price. Then that is a private. Price is a private here, and now this turns the method into a getter property. Just a at the rate property, and now define price dot self return price, and when at the rate price dot setter self and new price. If a new price is greater than 0, and self dot add the new price, or else otherwise the price can't be a negative. Okay, as like a previous. Now let's test the core code. I am taking laptop as my product, and that is a MacBook, and the price is 80,000. Okay, see this. I am just printing my formatted output like a original price. Original price is a laptop dot price. Look at this. It looks like a normal attribute, but it's safely calling the @ property method. We just use our product and dot price. Okay, this price. And see our output terminal. Original price is 80,000. Now see how assign this another price for this, and laptop dot price. I'm assigning 50,000 now, and try to print this. And this is a discounted price. See the output terminal. Original price is 80,000 and discounted price is 50,000. This is what exactly what we done before, but now we just call this as a laptop dot price and laptop dot price. See the previous one, my account dot get balance and the function inside, and my account dot deposit, and I have to give this. But instead of this, I just laptop dot price, laptop dot price. Before I initially laptop dot price is 50,000 now. Let's shift our gaze to our second concept, abstraction. If encapsulation is about protecting data, abstraction is about hiding complexity. When you drive a car, you press the gas pedal, which is an accelerator, and the car moves. You don't need to know how the fuel pump works, how the spark plugs fire, or how the transmission shifts. The complexity is hidden from you. Just we are driving a car with a gear, or if it is an electric vehicle, we just use accelerator and brakes and steering. We don't need to know how these all are working inside, right? In Python, we use abstract base classes to enforce rules. Sometimes we want to create a parent class that is so generic. It should not even be allowed to build an object. It exists purely in a rule book for a child class. We use so many functions and so many methods with the help of that parent class, right? In same way, let's build a payment processor. Here is the we are using Python's built-in ABC model. Observe this very carefully. Firstly, I am trying to importing the ABC module. We know how to import the one. From we have three different ways to import. One is a full module and a specific one with aliasing. Now, from ABC, import ABC abstract method. Now, creating an abstract base class. For this, my class is payment processor. Here I'm giving a imported module ABC. I'm also using a decorator here, which is a ABC abstract method. Now I'm defining payment pay as a self as usual, comma amount, right? I'm here just pass this function and then we'll do it later. Now I'm creating a child class is a credit card payment, and for this payment processor I'm defining pay as a self, comma amount. Here I'm trying to print this is from credit card, payment is from credit card, so I am printing processing a credit card payment of rupees amount. I'm also creating another class, child class, which is a phone pay payment. Amazing, right? For this I am taking a payment processor. Here I am defining a pay as well as self and the amount, right? Here I am printing the like a previous credit card. Now I am payment processing from the phone pay. For this I am formatting my output. Here I am redirecting to phone pay to process our rupees amount. Now I am testing the code. See the error. You cannot instantiate the abstract class payment process without an implementation for abstract method pay. Okay. Now, but we can access the child class. So let's see. Now, for credit card payment, I'm using credit card payment. So credit card payment, right? To the credit card payment, I'm using a pay amount. I can give 4,000. See the output processing credit card payment of 4,000. Now let's see what about the phone pay. Phone pay payment. I'm using a phone pay payment. I had to use phone pay payment dot pay amount. I can 200. Relating to phone pay to process 200. Here in the first one, from ABC import a ABC abstract method. We import a special tool built into Python. ABC stands for abstract base class, and the class payment processor ABC. By inheriting from ABC, we will tell Python this is a blueprint for blueprints. Do not let anyone create a generic payment processor object. We can't interact with this abstract class. Before that, instead of this abstract class, we are creating a parent class. We can interact with this parent class. Now we created abstract class. For this abstract class, we can't modify or any data or access anything. Now again, at the rate abstract method, we define a pay self amount. This is the ultimate rule. We are saying any child class that inherits from the abstract must have a method called pay. If it doesn't, crash the program. That's what will happen. Without pay, it can't work. That's why you pass here. Abstraction helps you design a massive systems. If a team of 10 developers is building a 10 different payment methods, the abstract class ensures every single one of them correctly implements a pay method without you having to check their code manually. Now let's see what we have done in this video. We learn how to lock your data using private attributes, and you learn how to build a safe pathways to get data using getters, setters, and elegant at the rate property is a decorator. And finally, we learn how to use the abstract classes from the ABC module. It's like a strict rule book for software architecture. Here is the practice questions. Create a student class and give it a public attribute name and a private attribute name with before two underscores, that is grades, which should be an empty list to start. Use at the rate property decorator to create a getter that returns the average of student grades. Then create a student method called add grader self grade that acts as a setter. You need to give getter and a setter. It should all only happen the grade to our private grades, that is underscore grades. If the grade is between 0 and 100, and create a student, try to add a valid and invalid grades and print their average. Don't skip the practice. Getting these errors and fixing them is how you truly learn. In next video, we are going to dive into magic methods. Thank you for choosing H&M Technologies. And thank you. Happy coding and